Good afternoon, everybody. Welcome back again. What we're going to be covering today is lesson 30.02 part B. This is where we finish up with sine and cosine functions in terms of transformations. Yesterday what we looked at is graphing y equals sine of x and y equals cosine of x, but then more specifically we looked at the following transformations of those functions. Y equals a sine bx and y equals a cos bx. And although a and b did the same things to those functions that they did in Unit 1, namely a is responsible for vertical stretches and reflections, b is responsible for horizontal stretches and reflections, what was important about a and b in terms of these graphs is that if you take the absolute value of lowercase a, you will get what we call the amplitude of the trigonometric graph. And if you take 2 pi, if you want to work in radians, divided by the absolute value of b, you'll get the period. Of course, if you wanted the period in degrees, you would take 360 degrees divided by the absolute value of b. So although we can explain the work that we did last time based on stretches and reflections, the main idea has nothing directly to do with them. It has more to do with something you have to memorize, quite frankly, that A is going to lead you to the amplitude and B is going to lead you to the period of the graph. Well, what we're going to do today is introduce translations, shifts left or right and up or down. And if we put all of the parameters together, what we end up with is the following. Y equals sine of x becomes y equals a multiplied by the sine of, in brackets, b times x minus c, and then at the end plus d. And if we apply our set of transformations to y equals cosine of x, we end up with y equals a multiplied by the cosine of bracket b bracket x minus c n bracket plus d. And I hope it's not lost on you that we were using h and k for the translations parameters in the past, and all of a sudden I have switched to c and d. There could be a number of reasons why we don't use h and k, but I think the primary one is that k, when we're talking about sine and cosine functions, k is a letter that's reserved for period. So what we're doing here is we are using, instead of h, we're using c, instead of k, we're using d. Now I would like to go over what all of these parameters mean in terms of sine and cosine functions. And you need to understand that what I'm about to write here is true for both of these functions. I've already said this, but I'll rewrite it. If you take the absolute value of a, you get the amplitude. If you take 2 pi divided by the absolute value of b, you get the period. And again, if you wanted to get the period in degrees, you would take 360 over b. In terms of c and d, c is responsible for a translation to the left or the right, but we use different terminology now. C is called the phase shift of the trigonometric function. And d, which is equivalent to our old k in Unit 1, d is in fact responsible for a vertical translation, but what we call it in this unit with regards to sine and cosine functions is we call it the vertical displacement. And lastly, I want to point out to you something about the 2 pi over b equals k. Don't forget, and we went over this in the last lesson, that 2 pi divided by k would give you b. So you're able to interchange the b and the k in this equation. So what we're going to do is learn more about all of these parameters and the features of trigonometric functions by way of 3 examples today. So to begin with, we're asked to draw a complete, or my mistake, we're asked to complete a rough sketch of the graph and fill in the missing information for each of these 3 functions. Well, before we actually get started, maybe we should talk about the function y equals sine of x minus 30 degrees plus 3 in terms of parameters. If I have y equals sine, I can write that as y equals 1 sine. And if it's sine of x minus 30 degrees, then I can write that as sine of 1 multiplied by x minus 30 degrees. And then we have plus 3. So when we compare this to our template, y equals a sine b bracket x minus c n bracket plus d, it becomes pretty clear what a, b, c, and d are. A is 1, b is 1, c is 30 degrees, and d is 3. So before I go back to the graph, if a is 1, that tells us, that leads us to the conclusion that the amplitude of this graph is 1. And if b is equal to 1, that leads us to the conclusion that the period is 360 degrees over 1. The period is 360 degrees. And the reason why I'm using degrees is when I take a look at the equation, there was a degree symbol in it. And I can start to fill in information now. I know the amplitude is 1 and the period is 360 degrees. Now let me explain to you the significance of those 2 things in terms of sketching the graph. What the amplitude being 1 tells us is, and this is very subtle but important, wherever the middle of the graph is going to go 1 above that and 1 below that. Let's deal with that right now. Because of the fact that d is equal to 3, I'm going to go back here and fill in the rest. We have a equals 1, b equals 1, we have c equals positive 30 degrees, we have d equals positive 3. Because d is positive 3, the entire graph at some point is going to be shifted 3 units up. Now, you're not going to draw what I'm about to draw, but if I just looked at y equals sine of x, the middle of y equals sine of x is right on the x-axis, and the graph wobbles up and down above and below that. So if, and it doesn't matter whether there are stretches involved or not, if I end up shifting that 3 units up, because the vertical displacement is 3, that means the middle of the graph is going to be up here at 3. So this location for the middle of the graph, everybody, is always at the value of d. D is the vertical displacement because it tells you how far the graph has been shifted vertically. So the vertical displacement is 3. Now, if we start to put this vertical displacement together with the amplitude, and you can in fact draw this dotted line where I have it now, if the amplitude is 1 and the vertical displacement is 3, that means that the graph is going to go 1 above 3 and 1 below 3. So what we've done is kind of put in guidelines here. Whatever I sketch is going to wobble up and down between the top dotted line and the bottom dotted line, centralized around that middle dotted line. Now, for y equals sine of x, the graph normally starts, and this is the start point that we were talking about yesterday, the graph starts at the origin. But don't forget that that point, that start point, is only when the middle of the graph is at that location. If I shift the middle of the graph up 3 units, that start point will have shifted up 3 units with it. And now we can deal with the phase shift and then fill in the rest of the information. The phase shift is c, and c has a value of positive 30 degrees. And what that's going to do is it's going to take that start point and shift it 30 degrees to the right. So that start point went from here, it went up 3 and 30 degrees to the right. This is the new start point, and now we're just about done. If the period is 360 degrees, don't forget sine has a complete cycle, that has an up, down, down, up, and that's completed in one period. Remember that sine starts at the start point going up. So what we have to do is sketch an up, down, down, up from that green point to an end point that covers 360 degrees. And since this is at 30, 360 degrees added to it will take us to 390. Now what we have to do is sketch an up, down, down, up between those 2 points. So what we're going to do is break it into 4 pieces. If you look at the top of the screen, up takes you to there, down takes you to here, down again takes you to this point, up takes you to that point. We need to divide this into 4 sections horizontally. And you can draw this if you like. You don't have to. It's certainly not part of the graph. I can start by dividing this distance in half, which will take me to here. And then if I divide it in half again and again, that's a way for me to get the 4 pieces. So it has to go up. There's my first quarter, then down, and then back up. So what this graph looks like, and it takes practice to draw it, it has a curve going up, and then a curve going down, and then a curve going down, and another one going up. And you can go ahead and just put arrowheads on the end of it, and we're done with the graph. Now the maximum value is 4, the minimum value is 2, the range is 2 is less than or equal to y, which is less than or equal to 4, and the domain, of course, is x is any real number. So what we're going to do now is move on to the next example, which is a little bit more complicated because there are going to be stretches involved. All right, let's take a look at example 2. What I want you to do is take a look at the equation y equals -2 cosine brackets theta plus 2 pi over 3, then minus 1. Pause the video so that you can fill in the values of a, b, c, and d, and then when you're ready to resume, and we'll see how you did. A has a value of -2, b has a value of 1, c has a value of -2 pi over 3, and d has a value of -1. So let's fill in as much information as we can based on that. The amplitude is equal to 2. The period, since b is 1, is 2 pi. The maximum value, well, let's leave the maximum and the minimum and the range for now. The domain is any real number. The phase shift is what c is equal to. It's -2 pi over 3. And the vertical displacement is the value of d. So the procedure in graphing this is to recognize, and you don't want to draw this dotted line, but to recognize that the middle of trigonometric functions before they're shifted up or down, the middle is on the x-axis. And if we have a vertical displacement of -1, that means that this point, this line rather, is shifted down 1. So the middle of the graph, you can call it the midline of the graph, will be at -1. Now the amplitude is 2, and what that is telling us is that the graph is going to go 2 above the middle and 2 below the middle. And 2 above -1 is +1, and 2 below -1 is -3. Now, since we're dealing with a cosine function, cosine normally starts at the top. I'll just remind you of this. When you have y equals cosine of x, it starts at the top and it goes up and down. There's a middle line, there's a top, and there's a bottom. So cosine starts at the top, except that cosine would normally start at the top, but a is negative, and that has flipped the graph over vertically, which means it's going to start at the bottom. So instead of starting at the top going down, it's going to start at the bottom going up. Except there's one more wrinkle to this. And the wrinkle is that the phase shift is negative 2 pi over 3, which means it doesn't start at this point going up. It starts at negative 2 pi over 3 to the left, or 2 pi over 3 to the left. And I've given you a grid here where each square is pi over 3. So what we know is the graph is going to start at that point going up. We're almost done with this question. The period is 2 pi, and if you look at the grid, 2 pi is 6 squares. So this cosine graph is going to have to go through its 4 pieces. It's going to have to go up, up, down, down, and it's going to have to do that over a distance of 2 pi. So it's going to land in the same place 2 pi away, which is 6 squares, and that means it's going to end here. I need to divide this distance between these 2 points into 4 equal pieces. Well, it's 6 squares, so the halfway point is 3 squares in between. And the halfway point between those is 1.5. So I'm going to follow this 1.5 point down, or line down, until I get to the middle. Then I can put the next point. I'm going to follow this down to get back to the middle. And now I can sketch. I curve up, up. I curve down, down. And that's what the graph looks like. All this other stuff is just me trying to communicate to you on a video what I'm pointing at as I'm drawing this. The maximum value we can see is 1, the minimum is negative 3, and the range is 1 is less than or equal to y, which is less than or equal to negative 3. If you wanted to, you could continue this. I'll maybe draw just one more in here. I'm not sure it's really necessary. Up, up, down, down. And you could draw as many of these as you wanted to. I would like everybody to take a minute, and I'm going to warn you here that you may have to pause the video, and it may take you literally a minute or two to figure out the values of A, B, C, and D. So pause the video, figure out what A, B, C, and D are equal to, and then when you're ready, resume the video. All right, the value of A is clearly 3, and I can just jump right ahead and say the amplitude is 3. The value of D is clearly 2, and that means the vertical displacement is 2. And by the way, before we even continue, that means that the middle of the graph will be at 2. And since the amplitude is 3, it will extend 3 above the middle and 3 below the middle. So by you looking at A and D alone, you can determine the amplitude, the vertical displacement, the max, the min, the range. In fact, let's write this in. The maximum we can see is going to be 5. The minimum will be negative 1. The range will be negative 1 is less than or equal to y, which is less than or equal to 5. The domain is any real number. The period, well, let's leave the period for the time being. I hope you can see that b is 2. And I'm going to calculate the period off on the side. Do that right now. The period will be 2 pi over b. but b is 2. So 2 divided by 2 cancels. The period is pi. We can put that in the chart. The only thing that's a little bit different here is c. c is not pi over 3. c is pi over 6. And the reason it's pi over 6 is you need to factor that b value of 2 out of the 2x minus pi over 3. And you end up with x minus pi over 6. So you can see that c is pi over 6. I might have misspoken a second ago and referred to this number that I wrote pi over 6 as b. I can't remember. I just seem to recall I might have said and b is pi over 6. If I did, I apologize. I meant c is pi over 6. So how are we going to sketch this? Well, we know that sine graphs start in the middle going up, right? That's what sine graphs do. However, this graph has a c value of pi over 6, so I need to take that start point and shift it pi over 6 to the right. Then what I need to consider is that sine will have this 4-part pattern. At the start point, it goes up. There's the first part, then it goes down, then it goes down, then it goes up, and it does that in one period. The period is pi. So we need to draw that up, down, down, up, those 4 pieces, starting at this point and ending pi later. Well, if you look at the x-axis, pi is 6 units. So if I count 6 units or 6 squares to the right of that green point, it's going to take me to here. So we're left with kind of the same problem we had in the previous question. We have to split up those 6 squares into 4 equal chunks. So starting here and finishing here, the middle is halfway in between. So the graph has to go up and down to that middle, and then down and back up to the end point. Halfway between the first 2 points takes you to this point at the top, and halfway between the last 2 takes you to this point at the bottom. So the graph looks like this. And again, if you chose to draw more pieces to it, more cycles, go ahead. The phase shift, by the way, I didn't fill in, but it's pi over 6. You know, I've never had to teach this through video before, and this is especially difficult because I realize that as I'm teaching most of this, I'm pointing at things and I'm indicating things with hand gestures. So I really did do my best here. I hope it's good enough for you to get a basic understanding of this. Watch the video again if you have to. What you want to focus on to begin with, I guess, is what A and D are, because A and D give you those horizontal guidelines, where the middle of the graph is, where the top of the graph is, and where the bottom of the graph is. So I hope that was helpful. Again, I'm doing my best here, and sometimes it's a little bit difficult, but I think it went okay. On page 250 of your unit handout, question 1 and 2, do every question in 1 and 2. In question 3, only do A, and then 5 and 6 as well. Any questions that say sketch the graph, you do not need to sketch the graph. All right, have a great rest of the day, and we will talk to you later.